So hello everyone, let us solve today's GFG problem of the day, and the problem name is linked list matrix. So let us read the problem statement. So you are given a matrix mat of size n cross n, and your task is to construct a 2D linked list representation of the given matrix. So the question is pretty straightforward. You are given a matrix and you just need to convert it into linked list presentation. So let us see this first example and try to understand the question in more better way and find some solution out of it. So this is the first example that they have given, and this is the matrix that they have given. The numbers are, or the elements are 1 2 3 4 5 6 7 8 and 9, and this is the linked list representation of this particular matrix. So it looks pretty simple, like okay, we are creating a node, and yes, we again created all the nodes that are present in this matrix. So 1 2 3 4 5 6 7 8 and 9. So we think, yeah, this is the linked list representation and it's done, but it is not the case because we need to handle the pointers. And I have also said in my previous videos as well, whenever there is a question of linked list, all is the game of how do you handle the pointers. So in this question also, so one particular node, let's say we represent this node as something like this. So this is the data value 1 and it has two pointers, right pointer and down pointer. This right pointer would be pointing to its next element towards its right. This down pointer would be pointing to its next element which is downwards. So we just this creation of node is simple. We can just create node by writing new node and then data value whatever the matrix of I comma j is present. So we can create this new node, but we need to handle these pointers. How do we handle these pointers? That is the main question. So let us see how we will do that. So let's say initially in our linked list representation there is nothing. We are starting from the beginning, from creating the first node. So we will create this first node with data value 1. Now we need to set its right pointer as well as down pointer, but currently there are no elements to its right and there are no elements to its down. So we can't set its right pointer and down pointer now at this moment. We can assign it when we have these nodes present at their appropriate place. So currently we can't assign its right pointer and down pointer. So we will continue our iteration and we will now create a new node with data value equal to 2, because this 2 is the next element of our matrix. So we created this 2. Now if you observe carefully, this 2 is created. That means now we can handle the right pointer of this 1. So whenever this 2 is created, we can say its previous value, its previous data value, whatever was that, we can just set its right pointer to point towards him. But in code, how do we do that? So let's say when we are creating this data value 2, we are currently at position I comma j. So when we created this new node with data value 2, we can just write a if condition. If our j is greater than 0, what we can do, let's say we are storing this entire linked list representation in our answer matrix. So what we can say, answer of I comma j minus 1. Now what is this answer of I comma j minus 1? I comma j is this, so I comma j minus 1 will be this, obviously. So we need to set its right pointer to what? To I comma j only. So we will set its right pointer to answer of I comma j. So we are currently at I comma j and we will check if j is currently greater than 0. So yes, j is greater than 0, so it is 0th index, it is first index. Similarly, when we go downwards, there will be 1 index and 2 index, and here also 2 index. So currently at j position is at 1 and I position is also at 1. So yes, j is greater than 0. So now we need to take its previous node and its previous node's right pointer we need to point towards the current node. So current node is I comma j and previous node is what? I comma j minus 1. So I comma j minus 1's right pointer will be pointing to I comma j. So that is what we are doing. Now what we will do, so let me just erase this part. So let me just, so now what we will do, now is the turn to create the third node. So third node will be have data value 3. Now again we will have this if condition. If j is greater than 0, point its previous node's right pointer towards him. So okay, 2's right pointer will now point towards 3. Now 3's right pointer will be default to null only, and down pointer also to null only, but we will handle that down pointer now. So let's see how do we do that. Now we are like created this third node. Now it's time to create the fourth node. So let's say we created this fourth node. Now we need to handle the down pointer of this one. So what we can do, so similarly as we have seen in the j, like for the j pointer, when we are moving ahead, when we were supposed to set a right pointer, so we altered the value of j. So when we are going downwards, what value is changing? I value is changing. So similar to that j condition, we can write for the I condition as well. So if I is greater than 0, what we can say, answer of I minus 1 comma j, its down pointer should be pointing to answer of I comma j. So let me show you what is happening. So this is currently I comma j, and this is nothing but, let's say, I minus 1 comma j. So yeah, we have created this node and we are currently at I comma j. So we can check if I is currently greater than 0. Yes, I is greater than 0. I is currently 1. So we need to set its previous pointers down, previous node's down pointer to point towards himself. So what we can say, its previous node. What is previous node? Previous node is nothing but I comma j, I minus 1 comma j. So we can say answer of I minus 1 comma j, its down pointer should be pointing to current node. Current node is what? Current node is 4. And how do we express in terms of I comma j? It is currently we are at I comma j, so we will write answer of I comma j. So this will handle the case of down pointer. So similarly, when we are here, we will create 5 node. Now similar to that, so let me create this down pointer as well. Yeah, so 2's down pointer will now be pointing to 5. Similarly, when we create this node 6, 3's down pointer will now change its null value to 6. So 3's down pointer will now point to 6. Now what will happen? Node 7 will be created, and yeah, side by side this right pointer will also get handled with the j condition as we have seen previously, and 6 right pointer will be pointing to null. So this null is by default. You can check in the GFG as well. They have provided initially the right pointer as well as down pointer are set to null. I'll show you and I will code it, but yeah, you can just see it right now. So when we are creating this node number 7, we will handle this down pointer. Now node number 8, so 7's right pointer, 5's down pointer. Now node number 9, 8's right pointer, 6's down pointer. And by default 9th right pointer will be null and down pointer will also be null. Similarly, 8's down pointer will also be null and 7th down pointer will also be by default null. So this is how we are creating this linked list representation of matrix. So hope you understood this part. So let us directly write the code now. So before that, I wanted to show you the by default right value and down pointer value. So you can see right is null and down is also null initially. So let us directly write the code now. So initially we will define a variable n, which will be nothing but size of the matrix. And now what we can do, we can iterate over this entire matrix with the help of 2 pointers. So we can write something like this, and now we are iterating. So first what we need to do, we just need to create a new node. So what we can say, node star, let us say we gave the name of new node equal to new node, And what data value it will have? Its data value will be nothing of mat of I comma j, which they have already provided in the input. So we can say mat of I comma j. So this will have the data value. Now what we need to check, so when we are iterating, there will be condition when j will be greater than 0 and I will be greater than 0. So why we are checking this condition? To handle the right pointer and down pointer. To handle the right pointer, this condition should be followed, and to handle the down pointer, this condition should be followed. So we can only set a node's right pointer and down pointer once its next node is created. So that's why we are writing this. So if we are currently standing at I comma j, so at this moment we can't set its right pointer and down pointer. We can only set if their down values node as well as its right node is created. Then only we can point it to their corresponding right and down node. So that's what we have seen in the drawing explanation as well. So that's why we are writing this condition. So now if j is greater than 0, what we need to do? We need to take its previous node's right pointer to point towards current node. So what we have seen? So one thing we forgot to initialize is the answer matrix in which we will be storing this entire linked list representation. So what we can say like that, it will be in a form of node star, and we will give the name of answer. So answer of n comma n. So it will have n rows and n columns, and each row column will store one particular node of the linked list. So what we need to do, when we are currently at I comma j, we need to set its previous node's right pointer to point towards itself. So what we can write? Answer of I comma j minus 1. So this is the previous node. So its right pointer. So its right pointer to point to the current node. What is the current node? Current node is nothing but I comma j. So this will handle the right pointer. Now similar is the case for down pointer. So when we are currently standing at I comma jth node, its previous node would be what? I minus 1 comma j in terms of row and column, and that node's down pointer will be point towards itself. So how we can write? Answer of I minus 1 comma j, its down pointer should be pointing to answer of I comma j. And yeah, this was it about the code. So we are just iterating with the help of for loops, and we are just changing the right pointer and down pointer to corresponding nodes. And in the end, we need to return the head of the our matrix. So what will be the head of our matrix? It will be nothing of answer of 0 comma 0. So this should work fine. So let us submit if this gets accepted or not. So it is giving some error, so let us see. So yeah, it is giving us error because we forgot to do one thing. We created this new node, but we didn't put it into our answer matrix anywhere. So we need to put this current node into our answer matrix also. So answer of I comma j will be the new node. So we forgot to put this new node into our matrix, so that's why it was giving us the error. So now I think it should run perfectly fine. So let us see. So yeah, our code got accepted. So hope you learned from this video. Thank you.